I am here with all of you with four of our experts who will be talking about a topic relevant to our day-to-day needs of life today now. The topic is NLP, that is natural language processing. With the advancement in technologies and fields like IoT and AI/ML emerging, the relevance of NLP has become more important in our day-to-day life. More user interference through verbal communication has started instead of switches, buttons, or commands being given by the users. And for that, translating human language that is easily understandable by machines has been taken over task by NLP. And in few years, last 3-4 years, a lot of research has been done in this domain. And today again, we all have assembled together to discuss similar points. So we have 4 experts with us. First of them is Dr. Just give me a minute to open her profile. Give me a second, friends. So we have Assistant Professor Mekala R. She is Assistant Professor in Department of Information Science and Engineering at Bannari Institute of Technology. She is B Computer Science in 2008, ME Computer Science in 2010, and PhD pursuing. Previously she was working with KS Rangasamy College of Technology, Tiruchenagode, sorry, and she is having totally 12 years of experience. She will be talking to all of us on the topic where she will be discussing NLP used for sentiment analysis and large language models. So I welcomed Assistant Professor Ma'am to take over the session and discuss the topics with all of us. Welcome, ma'am. Ma'am, you can share your screen, please.
No, Professor. Just now, Mekala, Assistant Professor, has called me. She has some issues in connecting. Can we go with the next speaker, please?
Okay. Just fair enough. So next, we'll be talking with Dr. Mannat, and she will be talking to all of us on introduction and applications of NLP in various domains. So I'll go through her brief profile once. So, Dr. Mannat Doultani is Assistant Professor with VESIT since 2010. She is ME and BE in Computer Science. She has been teaching various subjects like database management system, programming approaches, web technology, and data analytics, and many more. She will be talking to us about NLP and its applications in various domains. Welcome, Dr. Mannat. Please start your session.
Good evening, everyone.
Dr. Mannat, can you share your screen, please?
Yeah, yes. Give me a minute. Is the screen visible? Hello?
Yes, ma'am.
Okay.
Yes, ma'am, it is visible now.
Good evening, everyone. So I'm Mrs. Mannat Doultani, Assistant Professor in Vivekanand Engineering College. I'm here to brief you about what is exactly natural language processing and the umbrella terms used along with it. So, we'll be going with the flow. Like, first, we'll be talking about what is exactly AI, then machine learning, and how the both are related with natural language processing. What is the relation between the three in the exact manner, and what all applications are till now being covered with NLP, or how NLP is influencing our lifestyle. Just a brief introduction. So when we see AI now, AI is like a very fascinating term in today's life. When we say AI, all the students, all the teachers are like, "Oh, it is something great." But if we have a simple understanding, it is nothing more than human brain. The brain now, till now, the human brain which is being doing, we are now trying to make our machines do in the same way. So just we need to transfer whatever human brain is doing till now. Now we want our machines to do the same. So basically, artificial intelligence is the ability of a machine to perform the tasks that were done by the human till now, such as reasoning, which we keep on doing, knowledge representations, planning, learning, perceptions, support for. Now, this is something like the advanced level, and last but not the least, the natural language processing. So AI is something we want machines to be working like human beings. So there are three stages of AI: basic level, mid level, and the higher level. So if we see, the first level is artificial narrow intelligence, which is abbreviated as ANI. So it is the basic level where you start working with simple chatbots, and then we have general AI, and then the super intelligence. Super intelligence covers robots, the high profile robots which actually work like human, and general intelligence is the midway, the machine learning algorithms we incorporate, and we keep on making our machines learning along with some AI models. So if we take an AI project, what are the steps involved in it? Is first we need to identify the problem, then problem scoping. As we know, the AI is very vast, so we need to limit each and every problems statement to a particular scope. And then as per the scope, we need to acquire the data. We need to clean the data, explore the data as per the need of the problem statement. Then we need to build the models. Now, what are actually models is, AI is like, as our brain keeps on learning from the events or from the surroundings, we want our machine to learn from the iterations which it keeps on performing. So we develop a model which keep on learning from the iterations. So we need to develop the required model as per the problem statement. We keep on evaluating the results. We keep on evaluating the results and keep on refining the problem statement as per the results. So this is an cycle which we keep on repeating unless and until we get a desired output for the timing, and then we keep on again learning, and then we keep on again improvising the problem statement. But here, not the human brain is involved, but we want machine to do the same. So AI, and next is machine learning. Now, as the human brain learns from the surrounding, from the experience, we want our machines to do the same. So machine learning is a branch of AI. AI is an umbrella term in which one of the term is machine learning, and computer science, which focuses on the use of data and algorithms to imitate the way the humans learn and keep on improving the accuracy. So basically, AI gives you the platform in which machine learning keeps on improving the output of the algorithm uh, by improvising the data set, keeping the watch on the algorithm. What are the traditional goals of ML, machine learning? We want our computers to become smarter and smarter, and we have seen how it has been doing that. To develop computational models of human learning process and perform computer simulations. So as it has become smarter, the computers have eased the job of the human beings. The study in this aspect is also called as cognitive modeling. So when the computer replaces the human beings with the help of the models, with the help of the algorithms, we call something as cognitive modeling. To explore new learning methods and develop general learning algorithms. Maybe in the starting we had some few of the algorithms, maybe 10. Then we kept on mixing, learning, improvising. Now we have n number of algorithms which we can again mix and match and keep our machine keep on learning and improving the output for our algorithms. Now, types of machine learning is supervised learning. Here we provide the data in supervised learning. We already know what may be the output, expected output. So we provide the training set where already the labels are being defined. When we provide the test set, we are sure that out of the three, these will be the output. One of them will be the output. But when it is unsupervised learning, so it is basically using predictions, and reinforcement learning is you learn from the past iteration. Okay, so these are the three types of machine learning algorithms, types of machine learning which we can perform. The steps involved in machine learning is, again, first thing is gathering data as per the required problem statement. Maybe you are predicting, say, the weather condition in the next week. So you'll be requiring the weather data. Now, the data you are getting is in the raw format. So you need to prepare the data, uh, cleaning out the unwanted one. Then you need to choose a model, the predictive model, the classification model. So you need to choose a particular model. Provide the training data. So the data which you're getting, you need to divide it into the training and testing. So you, to that model, you'll be providing the training data. You'll be having some of the evaluation measures where you can check the accuracy, the efficiency. So on that basis, you will be you'll be doing the evaluations, and then hyperparameter tuning. So for example, as I said, you need to predict the weather in the next coming week. So there can be 20 parameters in your data set. So not all the parameters will contribute to your result. So what all those parameters are there? You need to find out the major parameters, and we need to uh, uh, test the data, the model on the basis of those particular parameters, and then we we get the prediction based on that. So we need to identify those parameter and do the prediction, and in the end you get the result in the form of the prediction. So in AI we have one of the uh, uh, term called machine learning. Next comes the natural language processing. Now, natural language processing uses both the AI, the machine learning. Along with that, it uses some rule-based modeling of human language. Now, there are n number of human spoken languages. So, if we consider the basic one, say the English one, so there are some rules already defined for the English language. Okay, so that human language, the basic rules are also fed into the system, and along with that some machine learning, statistical, and deep learning. DL stands for deep learning models. So all the three mixed up, and then we get some miracle to be happened, like we have Alexa with us, Google Assistant. Okay, so what is actually natural language processing? It refers to the branch of computer science, and more specifically the branch of AI. So again, it comes under AI, concerned with giving computers the ability to understand text and spoken words. Now, it is very helpful for the challenged people. Okay, one which cannot read and write properly. So the text to audio, audio to text conversions are very helpful because of the NLP for them. So it considers the audio, the video, the text input. Okay, so understand the text and spoken words in much the same way the human beings can. Okay, so NLP has helped a lot. Uh, It is again the AI and machine learning a great combination along with the rule-based modeling of human language. So what are the basic steps or the phases involved in natural language processing? Now, this is the basic step, like how NLP can solve the problem. What are the intermediate steps involved? So we'll take one example, a simple sentence, and we'll see how it converts, how it helps, how it translates. Okay. So natural language processing, it takes a simple sentence, for example, the bird pecks the grain. So the first phase is the morphological analysis, which is again broken down into multiple steps. The first step is called as tokenization. Now tokens are nothing but the words involved in the sentence. So tokenization means the bird pegs the grain. This is the complete sentence. The becomes one token, bird becomes one token. So the words are being extracted from the sentences. So the words are being extracted like this. After that, what you do is you remove the stop words. Stop words means the punctuation marks or the articles which are not contributing actually to the meaning of the sentence. So the bird pegs the green. There are two articles, those are being removed. Okay, so these cleaning of the text is done in the morphological analysis. So we have got the three words from the sentence, bird pegs green. Now, next phase is the syntactic analysis. Now, syntactic analysis works on the grammatical structure. So, as we all know, we have studied grammar when we were in our school days. There are some rules defined. Okay, the sentence should start with the noun. It cannot start with the verb. Like we cannot say pecks bird grain. We have to go with birds peck grain, pecks grain. So there are some already defined rules. Okay. So if we are using Python, we have the library already inbuilt with a set of rules of the English language. So how it actually takes place is the model generates the parse tree. Now this is the sentence phrase. Now sentence phrase may have noun and verb. Now noun again can start with the delimiter or and the noun. So we have delimiter called the and the noun called bird. Now verb again can be divided into verb and noun. So we have a verb called pex and then we have a noun which can again be divided into delimiter and this. So this is how the sparse tree is generated. Now we cannot have a noun phrase starting with like verb over here. Okay, so sentence which will have like left to right. So noun first and then the verb. We cannot have at the left the verb. So sentence is being, so this is the parse tree which is generated. So bird pecks grain, this is the valid thing. Pecks bird grain, this is not a valid thing. So the sparse tree is generated in this particular phase, and then the grammatical structure is being checked and the correct and incorrect sentences are being uh, classified. Next, after the syntactical analysis is done, we have a semantic analysis where we are actually concerned with the meaning of the sentence. So for that very purpose, we have a semantic graph, something like this, which is generated. For example, we have two sentences. She drank some milk. She drank some books. Now, these both are considered as sentences. But if we check the meaning, which is having the valid meaning and which is having which does not have a valid meaning. So how do we check it? Drank is not a base word. Base word is drink. Okay. So we have a base word over here, drink. Now the semantic graph says to the drink, we have many of the other nouns and verbs connected. So drink, if we see, is connected to beverage over here. Again, beverage is connected to liquid, milk and food. But drink is not nowhere connected to the books. Okay, and if there is a connection also, it will be quite far. Okay, so the nearest one which we can find is over here is the milk, not the book. Okay, so it means there are some meaning connection between the words called drank and milk, because some and she are the same. So drank and milk. So this is just one example. We have more the complicated ones. So drank and milk, they have some connection in the semantic graph, and then we find the meaning, and hence we select a particular sentence. So this is what happens in semantic analysis in NLP. So they find out the proper structuring and meaning of the sentence. After that, there are some more things to be considered in NLP. For example, she likes to read a book, and she likes to book a book. So we have book as a verb also, we have book as a noun also. So what is the exact meaning? Are the two sentences correct? When it comes into the picture, when there's some ambiguity in the sentences, which human mind can resolve, but if we want the system to resolve it, okay, so again the models and the algorithms we need to apply. So that comes in pragmatic analysis phase. For example, if we consider monkeys eat banana when they wake up. Here in this particular sentence, they means monkeys. Now consider this example, monkeys eat banana when they are ripe. Now they over here means banana. Now this human mind can easily make out, but what about the machine mind? So we need to train it, and NLP is still in this phase to solve this ambiguity and have achieved some kind of accuracy. Okay. Again, in the pragmatic analysis, we have examples like close the door, please close the door. Now, what's the difference? The first one is considered as an order. Now, where the word comes please, it turns into a request and affirmation. Okay. So in pragmatic analysis, we try to resolve this part, and at the end, we predict or we provide the result. So at the end, knowledge discovery, discovering valuable information from a sophisticated and unstructured text. That is the last step. So these are the phases involved in NLP. Okay. Now, what is the relation between the three? If we concentrate on this particular diagram, you can see AI is the superset of your machine learning and deep learning algorithms. And we have a computer science as one set and human language as another set. Now, when AI, computer science, and human language join hands, we get a new thing done, which is called as NLP. NLP cannot be a single ML algorithm, AI algorithm. It has to consider the human language as the major part. So when these three supersets combine, we can have something called NLP. That there's much more involved in the phases of NLP, but to have an overview, these are the phases involved. So NLP is nothing but combination of AI, ML, computer science, and human language. Now, what are the areas which are being influenced by them? We have NLP, AI, ML, everywhere we see now around us. Okay, so smart cars, navigation apps, facial recognition, text editors, social media feeds. Now, if I consider for say example smart cars, so you cannot say it only has AI, because smart cars have the assistant, voice assistant, again which involves NLP. It will provide you directions, it will answer your questions. Okay, so smart cars has AI, ML, and if you have like an object, now it is being detected, but later on it may detect the faraway object more clearly, so ML will be involved in that. Okay, so machine learning comes into the picture, and then the voice assistant and the question answering which goes on. So smart cars has three of them. Then you have navigation apps. The best example is your Google Maps. Okay, so it involves AI, it involves your machine learning. Of course, it involves voice assistant head, though it is not communicating, but it gives you the voice assistant in different languages. Similarly, the rest chatbots, very helpful. Now each and every industry is having like a page website where you have a option of chatbot which can help you in chatting and provides you the basic question and answers, which you may go there and waste your time in the reception on the reception and ask them. Okay, so that thing can be done on the chatbots. Again, smart assistant, we have our Alexa, Google Assistant, e-payments, searching algorithms, media streaming. Everything involves AI, ML, and NLP. So these are the areas, applications of natural language processing. So smart assistant, document analysis. I would like to bring you the example of Google. So when you get a mail, we have three options. For example, there is a mail coming from the student requesting something. So we have three options. I'm not accepting, I accept, will do it later, something like that. So it is doing my document analysis, like reading my content and giving me suggestions. Okay, so this is one part of NLP done. Online searches, when we mistype on Google, it gives us some options like, are you searching for this one instead of this? So this is again the NLP part. Predictive text, WhatsApp, when you type something for the twice or thrice, you get the options which you directly click and then it comes on. Automatic summarization, when you type a document, you again get the suggestion, you just need to drag it and then it is being done for you. Social media monitoring, chatbot, sentiment analysis, all these spam filtering. Okay, so sorry, this slide is incomplete. I wanted to have some more examples of the companies using all these technologies. My son is not well, he's in hospital, so I couldn't complete the thing. I'm very sorry for that. So but I think you have got an idea where is NLP, AI, and ML leading us. So thank you for listening, and thank you, sir, for providing me the opportunity.
Thank you, Dr. Pankaj.
Thank you, ma'am. I was, it was an excellent presentation, and I like to share a small story or a small reel translated into my words.
Okay.
So somebody was telling to keep your data off while you are not on your phone.
Okay.
So I asked that person, why should I do so? So they said that the machine listens what you speak also,
Yes, yes.
and it will use that for digital marketing, or it will use it for your information being registered on your Google logs.
Yeah, that's true, sir.
So this is the power of natural language processing.
Yes.
Voice recognition has taken this, means if you are, even if you're not working on phone, you're not surfing anything, you're just speaking to your family members or your friends, and it is going on record on your phone also, and you might get advertisements for it also.
Yeah.
So this is
We
what
experience
NLP has
in
helped,
this
and ma'am, you have shared very good examples of how data parsing is done, and how we can translate the translation of the data is done using NLP in sentiment analysis or various applications of it in real life.
Yeah.
Thank you so much, ma'am.
Yeah.
It was an
Thank you, sir.
excellent presentation.
Thank you, sir.
Hello, am I audible?
Yeah, yes, Doctor.
So we'll be having next session now of sir. Ma'am is available now.
Yes, Professor. Menaka is available. Mekala.
Mekala, Professor Mekala
Yes,
is,
sir.
and
Yes, sir,
I
I'm
must
available.
appreciate Professor Mannat for sparing her time. I was told her son is not keeping well, and I think he's been hospitalized also. Still, she has taken
Yes.
this valuable time. So hats off to you for ma'am for taking this session after that also.
Thank you, sir.
Thank you, ma'am. And I'll coming back to Professor Markle for her session on this uh, sentiment analysis and multi-models. Ma'am, if you're available, we can start the next session, please.
Yeah, sir. Shall I share my screen?
Yes, ma'am, please, you can.
Yeah. I hope it's visible. Is it visible, sir?
Yes, ma'am.
Not yet. Yes, ma'am. Now it's visible.
Okay, sir. Thank you. First of all, I would like to thank the organizers for giving me this opportunity to take the session on sentiment analysis and large language models. Let's start with sentiment analysis. Sentiment analysis in our day-to-day life, we are using this for in every aspect. If we want to purchase any product, just we are analyzing the reviews. So it may be any online product. Just we want to purchase anything, we want to review the things on many more sites. Just we are analyzing the reviews, what the customers has given rating, what are their opinions, what is the outcome, what is the exact feedback they have given. This one is focused on the sentiment analysis domain. We can call this in another word opinion mining. Actually, the sentiment analysis in the sense, so mainly we are using to analyze the customer feedback. If any organization they are producing their product, they want to analyze the views from the customer. How the reviews can be, they may be available in the form of social media tweets or some other form of feedback also given. That is exactly in the form of text format. So it is really tedious to analyze so all the customers feedback, so that we are going for a NLP approach. So in that we have taken so any review that is available in any social media, Facebook analysis or Twitter, just we are extracting the data set through any kind of APIs. Then we are processing that text. So actually the text in the sense, we cannot process the exact text directly. We are simplifying them into smaller tokens. Then only the machine can do the exact mathematical calculation and analysis process. Sentiment analysis in the sense, mainly it deals with text only, so that we are moving on to NLP. NLP, which contains some pre-processing steps, as the Mannat ma'am said, it contains pre-processing steps. The first one is eliminating the stop words. It cannot process the entire data set. So only we need some keywords to analyze the exact sentiment, whether it is positive or negative or neutral or something. So that we are doing some pre-processing steps, eliminating the unwanted words, that is stemming and tokenization and lemmatization. Why do we go for lemmatization? Means sometimes the words have different meanings. We want to understand the context, different context. So in order to the context, what they meaning exactly, we need to go for lemmatization. That is the actual exact meaning cannot be changed in that. That is lemmatization. So next we analyze the importance of sentiment analysis. So mainly, so all kind of enterprises, organizations, they are using sentiment analysis. Why the sentiment analysis is considered to be important? So some kind of users, they may given positive feedback. Some of them may given negative feedback. So at the time we want to analyze which part we are lagging in the product, what features they are not satisfied. So in that kind of analysis is very important, so that we are doing sentiment analysis, through which we can make some meaningful decisions and insights from the data analysis. So mainly the exact areas we are using sentiment analysis are marketing and customer support, and social media monitoring and product development. So through which we can make some important decisions. If any part of the product that is lacking, some of them may need more concentration on that particular part, so that we can analyze, we can do we can do we can make some changes on the lagging part. Let us see how the sentiment analysis is working. So actually, the sentiment analysis part, this is coming under the NLP domain, in which we are using some ML algorithms as well as deep learning algorithms, in which we are taking text data as input, then we are processing we are including some algorithms to analyze the data. Before doing, we cannot analyze the data directly. We want to perform some pre-processing steps. After that, we are extracting some features. The features, in the sense, they are deciding the prediction part. That is whether the textual part that contains positive sentiment or negative sentiment. Some important features or attributes that are extracted from the input data or text. Some common approaches we may use here are rule-based methods, machine learning algorithms, and deep learning models. So what are the challenges we are facing here in the sense? As I said earlier, some of the words can have different meanings or multiple meanings. At the time, dealing those kind of words is very challenging one. We have to analyze the context. Context in the sense, what exactly they are meaning. Sometimes we need to handle sarcasm or irony words also. And sometimes we may need to handle the reviews that are available in different languages. We need to consider that also. So that time we are in need of text translation part also. So these are some of the common challenges we are facing in sentiment analysis. I am showing you one sarcasm tweet. So actually the customer is not satisfied. He is expressing his satisfaction in terms of tweet. You know, the tweet is so it's a small text that can be expressed within a small characters, 143 characters. See, the sarcasm here is, so thank you for sending my package to Hyderabad and flying me to Kolkata at the same time. Brilliant service. When we see this, actually it's we can normally we can say that it is positive feedback, but actually the customer is not satisfied here, since the package is sent to some other place and his actual destination is somewhere. So this kind of sarcasm words also we need to face. These are the areas we are applying sentiment analysis. So actually, so in real time, we are facing this kind of scenarios. Actually, if you are producing any product, you have to analyze the competitor also, so that you need to maintain your reputation also. So at the time, we are using sentiment analysis and the valuable customer feedback to maintain our revenue. Then customer feedback analysis, social media sentiment analysis, then market research. So sometimes people may want some of the items that are mostly selling. For example, Amazon, Flipkart, they are providing big billion day offers. So at the time, they want to analyze what are the items that are mostly selling, what are the items that are having less. So this kind of analysis they want to make. So at the time, they go with the sentiment analysis part. Then political sentiment analysis also. The parties also doing analysis. You might be heard news from the newspapers. So our next topic is large language models. LLMs. This is one of the buzzword currently we are hearing. So LLMs are nothing but it is a part of AI. We can so in which this is coming under the generative AI model, where LLM in the sense it is one of the large language model. It is also a model, AI model, in which we are feeding the input in the form of text. That is in the form of prompt. Prompt in the sense we can give the input as a text data that will give you the response that is related to your query. So nowadays the current trending LLMs or GPT-3 is initially introduced. There is some drawbacks in that. It contains data, so only up to 2021 year. So some of the recent data are missing in that. So GPT-4, that is one of the updated version. So that is, and also next one we are dealing with the transformer model. So transformer model, which is one of the so wonderful invention in the NLP domain. So in the year 2017, Google researchers who had invented a transformer model. So after the invention of transformer, only this LLMs domain is evolved, and they are doing wonderful things. So what kind of task we can do with the help of LLMs? So we can make this one makes our life more simpler. It can do any kind of AI works. So even so kindergarten children can do their assignments with the help of LLM, and even the developers who can ask their help to debug their code. And most of the data, mostly the LLMs, they can behave like a human in terms of speech and text. So mainly how it produced the result, it is based on the probability. LLM model is trained with a massive amount of data. So based on the web database it is having, it producing the results. Whatever the query we feed into it, it analyzes. So actually it is already trained model. Then it provides the response that are relevant to our query. That is based on the some mathematical processing is involved in that. So since as I told, the transformer architecture which produces good results. The background architecture used inside LLM is transformer. Whenever we give text input, it produces the result. That is, it is one of the sequence to sequence model. Transformer in the sense, it is a sequence to sequence model. It what is the actual use cases here means it is used to summarize the text data, and as well as it produces language translation, and as well as it produces all kind of AI data, that is sentiment analysis, and it helps us in our regular activities, coding, and our assignments, like that. Some text to image models also available, that is coming under generative AI, that is Dolly, that is text to image model. We can give some text in the form of some fantasy words we can include in that. It will produce some fantasy images. For example, a dog is having roses with umbrella. If we give input like this, it will produce the image like that. So next one is word embeddings. It is one of the main important concept in NLP, since the machine that can handle only the numeric values. So as a human being, we are communicating through various languages, but system can understand only numbers, zeros and ones. So that we are feeding the input in the form of text, that is in any mostly we are using English. That input can be transformed into number format. So that thing can be done with the help of embeddings. We can call it as word embeddings. The mostly used text embedding techniques are word to vector. So here we can make the numeric conversion in various ways. That is one hot encoding also available. We can label them with the zeros and ones, but that kind of conversion cannot handle high dimensional data. That is not suitable for high dimensional data, and cannot resolve the semantic relationship between the words. So that we are moving for some other higher dimensional word embeddings model. It is global vector model, shortly known as GLOBE, and fast text. So mainly this kind of word embedding models are used in the NLP models. I have given one example to understand the word to vector model. Here we have two sentences. The queen sits on the throne. The king sits on the throne. Queen and king, mostly they are having similarity. The words that are having similar features, queen and king. But how the vector can be calculated? So based on the similarity, the similarity features are calculated using the embedding concept, and we can represent this text in the form of vectors. So next we can move into the LLM. So I told you that LLMs, they can work based on the transformer architecture. This is one of the sequence to sequence model. Here we are feeding the inputs, that is in the form of text input. Then we can apply embedding. So inside we have some neural networks model that can do solve the computations. We can have normalization part also. Inside we have multi-hit attention mechanisms that can we need to consider some important words. What are the, for example, if you are entering some complex query in the sense, we need to concentrate more on the some important keywords and features. So at the time we go with some attention mechanisms. That is how the multi-hit attention mechanism is mentioned here. Here we have input embedding part. The next one is explaining the output embedding part. Here we have feed forward network. If we have any error, if it produces any error output means, again we can train the model so that we can optimize the errors in the text model that we have produced through NLP. And here we also using some activation functions of softmax linear model. Since here all the text inputs and outputs, they are based on the mathematical calculation, and it will predict the next token or text based on the probability only, that is output probabilities. So this is an entire transformer architecture. Inside transformer we have encoder and decoder structures. So here I have one example. So this is one input, milk, drink I. We need to convert this input into a we are translating this text into some other language. So so we are feeding 3 text inputs, the corresponding vectors. They have been given with the help of embedding model. Then it is passed into the next layer in order to translate them. That is embedding lookup model. Here also the corresponding words has been translated in the concerned language. Then it will identify which word to be positioned next. That is applied with the help of sequence model. So usually, so it compasses the tokens and analyzes and then rearrange the words according to the translation. So based on the similarity, It can, based on the similarity as well as the probability, it can rearrange the words. This is how the sequential model is working. This is attention mechanism. Since attention mechanism in the sense that is based on the working based on the weights. So which are the words that are having highest weightage? We have to give more importance on that. So based on that, your model is working. The corresponding vector, attention vector, that is passed on to the next layer. So here are the applications of LLM. So mainly we can use LLM for the major works, that is text generation. So like if we feed any lengthy document or a large research papers, it can create some summarization part, that is text generation. So or either we can give some topic into the LLM model, and we want to produce some MCQ from that, that is question answering part. This is how it simplifies our work. Then language translation, then sentiment analysis. This is most widely used part. So aspect-based sentiment analysis is another thing. So if we do sentiment analysis, means it produces feedback. So only on the entire product. Aspect-based means, for example, if any customer giving feedback, the battery is not long-lasting. So that particular item is considered. The cell phone is entire thing, but what is the exact feature that is holding the feedback? We want to analyze, means we can go with the aspect-based sentiment analysis. So next one is explaining the prompt engineering. It is one of the AI domain. Mainly it deals with the large language model, how to give the exact or efficient input for the LLM models. See, this is a input data. Sorry. Here the entire input text, that is we can consider it as a whole query that is divided into or passed into some number of chains, that is we can call it as a chain of thoughts. We can divide them into number of chain model, that is prompt chain. Then it can produce the output like this. Instruction prompt, how to effectively give the complex query, that is it explains how the query into a simple way. This is whenever we give the query, the corresponding prompt will be working like this. The sequential chain is passed like this. Whatever the keyword we have given, the corresponding results are retrieved from the databases. For example, if I have given the query in science domain, means it will search for the answers that are related to science document. It will search for the science document. Then math prompt, if I have given the query in any mathematical aspect, means it produces the query response in the form of from the database of maths. So like this, it analyzes. Here we have one embedding router. Based on the prompt we have given, it the complex query is simplified into smaller prompts, that is a chain of prompts. Then it will looking for the corresponding responses. So next one is my medical applications. So this kind of LLM models, they are making wonderful things in medical domain also. So Palm, which is one of the LLM model produced by the medical industry. These are the use cases that are supported by the medical LLMs, that is consumer health search QA. So it can provide answers from the databases, live QA, medication QA, and PubMed, and medical MCQA. So these are multi-medical. This is question answering system. It can produce a response. Then MedFarm also another LLM model. Here on sample use case given, how long does a newborn, I think this prompt is not within. How long does it take for newborn to go away? Jaundice, I think jaundice to go away. The reply is given here. And we are comparing the human experts as well as the automated results here. Then another LLM that is related to medical use case is plan form. Here we have 3 samples. Just we are providing queries that are related to medical. How you treat the skin redness? Next one, why take simvastatin? It is a medicine. The response response that explains the use of simvastatin medicine. The next one, how can I split the 3 milligram or 4 milligram wafen pill so I can get a 2.5 milligram pill? So this kind of query is also answered. So next one, LLM prompt engineering. Here we have discussed some benchmark models. What are the embeddings that are supported so far that are compared here? Some so that is explained here. So totally we have some standard 58 data sets are taken. Then we are classifying the task into 8 different tasks. That is clustering, bytext mining, retrieval, and semantic text related. Then summarization, re-ranking, pair classification, and classification. So these are some benchmark questions that are using embedding model, passive text embedding benchmark models.
Ma'am, I'll be requesting you to compile the presentation in next few minutes. We are running out of time in that case.
Oh, okay, sir. So this one is, so next to business use case. This one explains so how the business use case that is supported by LM. So when we do manually we want to classify anything, we can use supervised learning. So in which it takes a duration of 3 months, 2 to 3 months, or if we do using LLM means it can take only hours and minutes. So this is how it simplifies our task. This is a production ready classifier model we are using in business domain. For example, if it's a customer question answer system means based on the user's response, it classify the customer responses into 3 categories: billing, account management, and general. So these are some challenges we can face in LLM. Reduce and measure hallucinations. So sometimes LLMs cannot produce the exact results. The results are not true or not exactly accurate results. So that kind of are not a sensible one. That term, so that kind of response is known as hallucination. Then we can run LLM only through the environment. That is kind of data centers. We can run LLM through GPU or some environment setup needed. And we can reduce the complexity of the query also. And we need to produce some GPU alternatives. And we can learn from the human feedback also. That is reinforcement learning and transfer learning is needed. And we can extend this LLM to some other that is non-English languages too. So finally, we can conclude LLM can produce some meaningful results to all the domains, and we can able to produce text summarization, we can able to understand the context, and we can do also all kind of NLP tasks with the help of LLMs. So, thank you. So, any queries, sir?
Thank you, ma'am Michael, for the excellent presentation. Sorry, it's Mekala, pardon me.
Yes.
Yeah, you have covered your presentation into two parts. First was a sentiment analysis. Today, where we buy every product on most of the products online, and reviews of users are either in video form or text form. In that case, especially when it's in audio form, NLP comes into a good role of it, and a lot of research is being done on this domain. And I hope in future also this will be helping us further also. Second part was your LLM part, where you can have multiple models of NLP working towards applications of what you call NLP in various domains of life. So hope these two applications, of course, it was quite technical part and it was excellent presentation by you. I hope everybody enjoyed it, and we will try to explore it further for our own research, and our colleagues will be more happy while going through it. Thank you, ma'am. Thank you, madam.
Thank you.
Now we have with us Dr. Dr. Vaishali D. Biradar. She is Assistant Professor at D.Y.Patil Institute of Engineering Technology, Pimpri, Pune. She is M.Tech in Electrical and Electronics and Communication Engineering. She is pursuing PhD in Bioengineering, and she has a lot of publications in SVM, machine learning, CNN, medical computing, and many more. So we will be enjoying her presentation, and her presentation will be having a topic that is on. Give me a second to read our topic, please, friends. Her topic is the future of smart devices with NLP. I hope Dr. Vaishali is there. Ma'am, please put your slide on, and we'll be going through this. Thank you, ma'am.
Yes, thank you, sir. Introducing nicely. I'm sharing my screen. Hope everyone visible with my screen.
Not yet, ma'am. We'll be waiting one few more minutes. Now it is getting up.
Okay. Thank you.
Yeah, it's visible now, ma'am. Now it's visible now, ma'am.
Yes. Thank you, sir. It's a great opportunity to discuss new technology with all. So my topic for this session is the future of smart devices with natural language processing. Already we, Mannat ma'am and sir told about the what is natural language processing and their application too. So I'm focusing on the basically one application, that is how we are using the smart devices with the NLP. So in this home automation system, it is my basic area of using the voice recognition. So first we see my outline of the presentation is introduction about the home automation system, how we are using nowadays, and how we are interfacing the devices with the voice, and some few algorithms I will discuss with you using the machine interface. So first we see what is the home automation system. So basically home automation system is a communication network comprising of home sensors, devices, and appliances, just like our light, fans, air conditioners, entertainment system, or any surveillance cameras, or any electronic door or alarm systems for the access of and monitoring of our home environment without any human intervention. So if smart home components having the means IoT device, which is connected to the internet, they can send up and receive the data from the global network, and thus we control remotely via different communication protocol. That is nothing but the concept of the smart home. Again, this smart home consists of the three different computing layers, we can say. So first, it is the data collection, and then processing and the storage. So in this, we are using the different layers. So in the middle of this layer, smart home architecture, which can be lies between the physical and IoT devices and the traditional data storage. Maybe it is the cloud storage. So intermediate layer, which can extend to the cloud infrastructure, and it can brings us the computations and storage closer to the data source. So when we say it is the many cloud computing techniques are there for that, as well as it is used for the processing as well as the storage, and we carry the remotely through the various servers. So whenever we are using this processing, then we can combine the sensors and actuators or cloud service in a single information space to extend the our user interface of the smart systems. So human machine interaction is an important factor for the adoption of new products by consumer electronics market. So we can say smart user interface increases sales and improves the corporate image of the smart system manufacturer. As well as when we say it is the innovative technique, human machine communication, it can be also useful for the customers, which can be quickly appreciate about the new technology, which can, whatever we are using the everyday lives. So many things we provide which can use through the IoT and the speech recognition. So basically some advantages of this voice user interface. So this is the classical one, which can be provide the additional control channel. Means when we say it is some handicapped person at the home, so he can only operate through his voice. He can switch off fan or AC or any lights by giving the only voice commands. So it enables users to perform multiple actions while communicating. So it is very beneficial, and it is means analogous with the everyday conversation also. Then it is beneficial to the people, as I earlier told, that is with the physical and cognitive disability. As well as several times we use this voice-based technology, which can be used as a language, means natural language understanding. So these platforms, further we are such as we are transcribing the speech to text one, or sometimes now Google having that AI tool, that is the which can convert our speech to text one, and we can search many things on the Google. So this speech to text or text to speech, especially natural language understanding services, which can now only available for the small subset. Again, services which can integrated on the smart home system often require the computer science competency, as well as it can support the significant amount of the time and effort. Then again, there are the many skills we can say which can be developed using this. But again, I will brief you about the what is the literature survey it is on this. So there are the various systems which can design the particular for the smart home system. So automatic speech recognition, Alexa is there, which can be used for the entertainment and all these things. Then we can, a voice user interface can be implemented only by the integration of the method covering all the aspects of natural language processing. That is the voice data entry, tokenization, lemnization, tagging, semantic, all these things are under the NLP. So, methods which are using the statically, we are using the hidden Markov model, dynamic time warping, Navy-based, as well as the support vector machine and logistic regression. So when we use the neural network, then we are using the convolution neural network, recurrent neural network, as well as for the deep learning, we are using the LSTM model, And distance based, we are using the term frequency inverse document frequency methods, or we can use the combination of the both. So since it is about the introduction of this home automation system, now we focus on the new framework, that is the voice-based user interface. This is the means actual diagram of the smart system, which is use the voice-based interface. So any smart home system have provided intelligent user interface, aimed of the maximum user convenience. So home automation system should guarantee effective remote communication between the control panel and other control system. So when we use this framework, as we seen in this diagram, that is we have to implement some one algorithm, we can say. It is called as the smart home system interaction via speech. So smart home user enters and means, or it can utters the speech with the certain meaning. Suppose A1. So user device means computer, laptop or tablet, records the speech and transmit it into an audio stream to a service provider by a integration of server. So this is basically, and the software IUI, a software module which can be response to the our recorded speech, and it requests given to the corresponding audio data. So it can extract the meaning of the input user utterance or speech, and it generates the request containing the obtained command for the smart home hub. The request again sent to the server that is in the cloud, that is we are using for the specially home automation company. We are taking care of the cloud server there. So this receives the request and it verifies its authenticity and the correctness, prepares and sends the command to the smart home subsystem, which is specified for it. So after this, all this process, the smart home subsystem receives the command, executes it and returns corresponding response. So these responses received by the automation company, and which transformed it to the your device. So it can be send the answer, or it can be give the some response to the your whatever the you are speaking about. So it can be give the prepare its own text response and it send it through a request. So the whatever the results received from the request, it may be audio file. So we can prepare the response specifying the URI, and it is received audio file and send it to the user device. The user device plays the audio file received as a result and their request, and the user hears a speech response by the system to their attorney. So this is the flow of our home system with the voice command. So there are various stages, we can say. It can be having the voice activity detection, ASR, again decision stage, communication stage are there, NLU is there. Detailed version of this means every stage it is having the some version. Again, we have to find out the shortest path of that. So we can see how it can be worked. Suppose this diagram, I think it is visible to all. This is the nothing but it is the how voice communication between the user and smart home system works. So in this flowchart, we can say that first algorithm it is repeated 1 to 5, but again steps means nodes, every nodes having the different this is the user, age, fog and cloud. That is every stage layer it is having some importance. So in this we can node represents a collection of the predefined information structure which is necessary to recognize each possible executable command. They are stored as a list of nodes. Each node contains a list of structure pattern as well as the list of slots as well as and the command generation mechanism. So structure pattern means what? it is the specialized syntax and it contains the words, the synonym groups, parameters, slots. Okay. So again, the position of the keywords, parameters, whatever we utter the speech, that is the basis of the detecting the correspondence between the utterance and the pattern. Then these parameters required by the command, specific questions for requesting the value corresponding the parameter from the user and defined for it. Command generation mechanism is a procedure in which the received command parameter values are processed and the formal command is generated for the hub. It can include other procedures using the external services. So this is about the whole flow of the our voice communication between the user and us. Basically, this is the, again, we are using this speech command detection also, using the second method also, that is the intent-based voice command. In this, all the nodes from the list of the predefined application nodes are traversed sequentially. That is the one difference between that. Then we see how these human-machine interface levels are there. There are many companies we are using which can interface this. Currently, we can say that is the BOS, Bharat Operating System Solution. It is said that 18 Indian languages such as Assam, Bengali, various languages we are communicating with this graph user in machine interface levels. Then basically we are using this as a database because we don't have all the languages database in this. So we are on the on screening keyboard. We are using all the Indian language using the virtual boards. So there are many development, that is the corporate building developed by the Central Institute of Indian Languages, which is the data having all the linguistic languages and which can give the speech database, okay, for the Indian language. So we can use this, as well as the CDAC also developed the speech corpora along with the text for 3 East India languages like Bangla, Assami and Manipuri. So for this, we have to make the e-content. Again, there are the 2 types of the e-content. We are using the online character recognition or online handwritten character recognition. E-content generation, we can, that is again, we call it the web-based education system, online tutoring, and the development with the different languages, MT tools, and the development of OCR, that is the optical character recognition. So all these tools are used to identify the languages. So again, we can just, I told you earlier, it is the text processing also, as well as text. There are the many how we are using in the question answer system, social sentimental analysis. Already ma'am work on the sentimental analysis. So basically, I'm working on the speech processing. So on this automated speech corpora for the speech processing of the any languages. So audio video search, how we can using the natural language processing. In that, I implemented the automatic speech recognition. The language user to do this, that is the MATLAB, and we means to design the one GUI. In that, we are giving the one input which can convert into the speech into the again audio file which is converted into the text and text to the again audio file. So that is the speech to speech translation system. Now that means I am giving the any input. It is in the Bangla language, then it can give the output in the Bangla language only. Okay. So this is very effective tool when we implemented that. So this is the just I'm telling about the speech processing, which is the if I given the input in the Hindi text or it can text to speech synthesizer for the Hindi, and for every languages we can use this. But I am user for the only Hindi language. So for my these smart devices future with the NLP, I have concluded with the That is the means many things are done in the automatic speech recognition among the most of the dynamic areas of the computer science. But we combine IoT for cloud architecture and the speech recognition, that is the new technology methods, to develop a new distributed framework for the smart home system with the voice user interface for the under resource language. Means those who know the Hindi, Bangla, or any Manipuri or whatever it may be, we can use that. So the new framework incorporates existing cloud services in speech recognition, STT and TTS methods, in particular smart home domain. Only the thing is that I am not included the limitation here, but some limitations are there for the defining the patterns for the smart home. Commands requires very good knowledge in a respective language. For example, in anyone having the any Slavic language, so belonging to that group, morphological rich languages, special attention is needed to different word forms. So there are the different patterns for the smart home commands. So prototype implementation can only handle a predefined set of domain specific voice commands, as well as for smart security system, only the one language can be used. And whatever I have proposed the methods, which is not supported to the tonal language, it's a different tonal language. So again, it is having the some limitation about the sentences. Few sentences are valid and few sentences are not valid. Again, we have proposed work is it is the single board computers we can say, and it can be modified for the voice commands interface as well as for the industrial automation. Then again, we can add voice commands for the monitoring and controlling the smart. So it is all about the smart devices. I have referred these some papers about this. Thank you, sir. Listening my session.
Thank you, Dr. Vaishali, for excellent presentation.
Thank you.
As Dr. Vaishali has illustrated that our life is becoming smarter every day. Now we use Fire Sticks to change the channels and use OTT platforms to play movies or play these things. All we use OTT platforms only, for which we use Fire Sticks like tools. We are not using remote CTC for switching on light, tube light, or fan, anything. We either use audio signals or we use just about mobile applications. Google has provided various interfaces. We can do that thing easily. So NLP has a huge role in IoT systems, smart IoT systems, especially in our day-to-day life. We are using audio signals to instruct commands to our machines, and this is another dimension of NLP where we have been exploring a lot of things in lot of research domains of NLP. Coming to next presentation, we have Dr. Pankaj Dadheech with us. Dr. Pankaj Dadheech is BTech, MTech, and PhD in computer science. He is professor in CAC in Swami Keshwanand Institute of Engineering and Technology, Jaipur. He has done his PhD in data analytics only, and he is expert in this domain. He will be talking about an evolution of NLP with CNN. And may I ask Dr. Pankaj Dadheech to start his sessions for the next another 20-30 minutes. Pankaj sir, are you available? Please, you can share your screen.
Yes, sir. So my screen is visible, sir. Hello. My screen is visible, sir.
Yes, please. Yes, please.
Yes. So my topic is NLP with convolution neural network. So this is the outline of the presentation. NLP, understanding NLP, then rule-based NLP versus statistical NLP, components of NLP is to use NLP libraries, current challenges in NLP, then advantages, disadvantages, applications, then CNN, activation function, LeanNet, AlexNet, and tools for convolutional neural network. So NLP as natural language processing is a branch of artificial intelligence that deals with understanding and generating natural languages such as English, Spanish, or Chinese. So NLP applications include speech recognition, sentiment analysis, machine translation, chatbots, and more. So to perform these tasks, NLP systems often rely on artificial neural networks, which are the models that mimic the structure and function of biological neurons. So NLP is combined as natural language understanding and natural language generation. So NLP is the whole process of turning unstructured data into structured data, and NLP helps technology to engage in communication using natural human language. So rule-based NLP versus statistical NLP. So you can see in rule-based NLP, it uses common sense reasoning for processing tasks. For instance, the freezing temperature can lead to death, or hot coffee can burn people's skin, along with other common sense reasoning tasks. So this process can take much time and it requires manual effort. Then statistical natural language processing, it uses large amounts of data and tries to derive conclusions from it. So statistical NLP uses machine learning algorithms to train NLP models, and after successful training on large amounts of data, the trained model will have positive outcomes. So this is the comparison, rule-based NLP and statistical NLP. So you can see that it is flexible. Rule-based NLP is flexible, easy to debug, doesn't require much training, understanding language, high precision, and easy to scale. Learn statistical NLP, easy to scale, learn by itself, fast development, high coverage. Some more in rule-based NLP, it requires skilled developers and slow parsing, and it has moderate coverage only. While in statistical NLP, it requires large amount of data and difficult to debug, and no understanding of context. So these are the components of NLP as already discussed. Lexical analysis.
I'd like to interrupt you. Really sorry for this. Dear participants, we have shared a link for attendance. Those participants who will fill the Google form will be eligible for getting the participation certificate. So I request all of you to fill the form by the end of the session, please. Thank you, everybody. Yes, Pankaj sir, please continue.
These are the components of NLP. Then what lexical analysis does. So in lexical analysis, we divide a whole chunk of text into paragraphs, sentences, and words, and it involves identifying and analyzing word structure. In syntactic analysis, it involves the analysis of words in a sentence for grammar and arranging words in a manner and shows the relationship among the words. And in semantic analysis, it draws the exact meaning for the words, and it analyzes the text meaningfulness. And in discourse integration, it takes into account the context of the text. So it considers the meaning of the sentence before it ends. So for example, he works at Google. In this sentence, he must be referred in the sentence before it. So this is another pragmatic analytics. So it deals with overall communication and interpretation of language. It deals with deriving meaningful use of language in various situations. So easy to use NLP libraries like Natural Language Toolkit, SPACY, and GenSim, Pattern, and Text. So in Natural Language Toolkit, this is the Python framework generally used as an education and research tool, and it is not usually used on production applications. However, it can be used to build exciting programs due to its use. The features is tokenization, part of speech tagging, and named entity recognition, classification, sentiment analysis, and packages of chatbots. So the pros and cons of this natural language toolkit is it is most well-known and full NLP library, and it supports largest number of languages. And the cons are the difficult to learn and use, and in the context of word is ignored. It is slow and no neural network model. Then in SPACY, it is an open source natural language processing Python library designed to be fast and production ready, and it focuses on providing software for production usage. The features are these tokenization, parts of speech tagging, name entity recognition, classification, sentiment analysis, dependency parsing, and word vectors. So pros and cons are the advantages are it is fast and easy to learn use, and it uses neural networks for that. And while disadvantages is that it is less flexible. Then GenSim, it is an NLP Python framework. It is generally used in topic modeling and similarity detection. And the features are latent semantic analysis, non-negative matrix factorization, and TF-IPM. So the pros and cons are it is intuitive interface, scalable, and having implemented algorithms. While the disadvantages are it is designed for unsupervised text models, and it should be used with other libraries. Then pattern, this is with the straightforward syntax, like it is powerful syntax for scientific and non-scientific tasks. So it is highly valuable to students, and the features are tokenization, part of speech tagging, named entity recognition, parsing, and sentiment analysis is there. So the advantages are it is having the data mining and network analysis and visualization, and disadvantages it is not optimized with specific NLP tasks. Then text block, it is the Python library designed for processing textual data, and the features are the parts of speech tagging, noun phrase extraction, sentiment analysis, classification, language translation, parsing, and wordnet integration. So the advantages are it is easy to use, intuitive interface to natural language toolkit, and it provides language translation and detection. And the disadvantages are it is slow and no neural network model is there, no integration word vectors are. So the current challenges in NLP, having the breaking sentences into tokens, it is the most challengeful, and the tagging parts of speech, it is also challengeful. Then building an appropriate vocabulary is challengeful. The linking the components of a created vocabulary, understanding the context, extracting semantic meaning, named entity recognition, transforming unstructured data into structured data. These are the current challenges in the advantages of NLP is it help or improve the human-computer interaction, the time efficiency and cost effectiveness, the data generation and context creation, the professional and business application, and it uses in advances in AI. So disadvantages of NLP were the possible issues with context and meaning, it having biased results from biased training data, issues with rare or out of vocabulary words, and the technical and computational requirements are there, and the possible ethical concerns and legal issues also. The applications of NLP machine translation, in speech recognition, in questioning, answering, in summarization of text, in chatbot, it is also application of NLP, intelligent systems, and text classifications. Then convolution neural network. So the convolution neural network, you can see the CNN is essentially having several layers of convolution, and in the three main types of layers: the convolution layer, pooling layer, and fully connected layer. So CNN are neural networks, and that uses convolution layers as their main building blocks, and convolution layers are composed of filters that slide over the input data and apply a mathematical operation to produce a feature map. So the feature map captures the local patterns and features of the input, such as edges, shapes, colors, or words. So convolution neural networks can have multiple convolutional layers, each with different filters and sizes, to extract more complex and abstract features from the input. So CNN also use pooling layers, which reduce the size and dimension of for the feature maps, and fully connected layers, which perform the final classification or regression task. So this is the activation function 1 by 1 plus ES to minus X. You can see this is the convolution neural network, how it performs. So this is the convolution layer. So in convolutional layer, so the convolution is the process through which features are obtained. These features are then fed to the convolution neural network. So the convolutional operation is responsible for detecting the most important features, and the output of the convolution operation is known as featured map, or a convolved feature, or an activation map. So you can see a CNN arranges its neurons in 3 dimensions, like width, height, depth. So every layer of a CNN transforms the 3D input volume to a 3D output volume. So this in linear, a layered model composed of convolution and subsampling operations followed by holistic representative and ultimately a classifier for handwritten digits are there. And in AlexNet, the layered model composed of convolution, subsampling, and further operations followed by holistic representation and all in the landmark classifier. So this is the comparison or the difference, LeNet versus AlexNet. So these are the in LeNet it having 32 into 32 into 1, and in AlexNet it having 224 and into 3. And it is having LeNet having 7 layers, while AlexNet having 8 layers, and these are the various comparisons. So you can see then CNN architecture. So the convolution layer and pooling layers are the main building blocks of a convolution neural network. So the conventional linear structure, linear list of layers or feed forward, it is generally using directed acyclic graph DAG, and the residual network simply adds back. So a traditional CNN are just a few complex convolutional layers to extract features and then followed by a complex classification output layer. Then convolution neural network output a high dimensional structured objects rather than just predicting a class level for a classification task or a real value for a regression task. So it is an output sense. So the popular CNNs are LeNet. It is defined in 1998, AlexNet in 2012, VGGNet 2014, and ResidualNet in 2015. So in LeNet, the first successful applications of convolution neural networks developed by Jan LeCun in 1990s or 90s. So it was used to read zip codes and digits. Then AlexNet, it is a popularized convolution neural network in computer vision, and it is developed by Alex Krzyzewski and Eli Sutesker and Geoff Hinton. So it is submitted to ImageNet challenge in 2012, deeper, bigger, and featured convolution layered with stacked on top of each other. Then ZFNet, it is expanding the size of middle convolution layers and making the stride filter size on the first layer small. VGGNet, it is become known VGGNet in 2014, developed by Karen Simyan and Andrew Jesserman. So the main contribution was in showing that the depth of the network is critical component for good performance. So it is having these 16 layers, only 3 into 3 convolutions or 138 million parameters. Then residual network developed by Kaming He and its partners, the winner of ILS VRC in 2015. So it features especially connections and the heavy use of batch normalization. And it is currently by far state of the art of convolution neural network model and are difficult choice in practice. So you can see here the weight layer. It is passes then from the weight layers. It is passing through various layers, and then there are 152 layers and residual net 15. The function is fx plus x. So these are the various tools for convolution neural networks. So the Convent, MATLAB, the CPU, GPU, Python 2 in Python, TensorFlow for Google, open source, Cafe, WebNet for generating human speech by DeepMind, Catapult, Microsoft. So these are the various tools in convolution neural networks. So we can see the convolution neural networks are multi-layered artificial neural networks with the ability to detect complex features in data. So for instance, extracting features in image and text data, and it is majorly being used in computer vision tasks such as image classification, object detection, and image segmentation. So when convolution neural network applied to natural language processing, so the pre-trained word embeddings can help in increasing the accuracy of text classification models. So you can always train custom word embeddings just like we have done However, using pre-trained word embeddings is advantageous because they have been trained on millions of words. So obtaining such a data set would be a challenge, and furthermore, training such a massive data set requires a lot of computation power. So finally, we can see the CNN and N are not mutually exclusive, and they can be combined to leverage their strengths and overcome their weaknesses. So CNN and are neural networks that use convolution layers, and it is also use pooling layers, which reduce the size and dimensionally of the feature maps, and fully connected layers, which perform the final transformation of the feature class. So this is all from my side. Thank you, sir.
Thank you, Doctor.
Pankaj sir, it was an excellent presentation. How NLP and deep learning can come together to bridge the gap of research being done in NLP in various domains, whether it was IoT discussed by Dr. Vaishali or medical application discussed by Dr. Malarkar. Sorry, I might be pronouncing her wrong name, or some other application. So what can I find is NLP has evolved and is part of life now for all of us, and a lot of research can be possible into this. And we have explored in last 1.5 hours or so. We have explored a lot of possibilities of NLP being used in our day-to-day life. We are getting good feedback from audience also. Just we received one feedback, and I thank all the four session speakers who have delivered an excellent presentation. And I thank all the participants who were there in the session. And I especially thank Dr. Krishnan, who has taken a lot of pain to organize this session. Especially, he was not keeping well. 2 days back, we had a discussion, and he was not keeping well. Still, he has been quite active and to organize all the things in right place. Thank you, and so hats off to you to your spirit. Thank you for giving me the opportunity to host this session on your behalf. I hope all of you enjoyed it, and a lot of learning would have come to you. At least I have a lot of learning out of these sessions. Thank you for all of us for joining, and meeting you all soon on another domain of research we will be discussing next. Some other sessions organized in future is on the similar lines. Thank you, everybody. Thank you, Dr. Pankaj. Thank you, Dr. Krishnan. Thank you, all the speakers. Please.
Thank you all. Thank you, Professor Dinesh. Thank you very much.
Thank you.